Hi there. In this screencast, I'm going to be showing you how to download some image digit data and visualize that in R. So in the elements of statistical learning text, we have the zip code dataset. Now here, we're just going to download the train dataset. Here, what I'm going to do is copy that, open that in a new tab. Well, actually, let's cancel that. Right, yeah, so opening in a new tab, it's a GC file, all right, so it doesn't display it by default in the web browser, that's a gzip, so it's compressed file. So what I'm going to do is I'm going to get an R script where I'm going to say if not file exists, zip train. I'm going to do download file, get that zip train .zz. And so here we go. Now I have that file downloaded. Now we can use fread, data table, fread on that zip train.gz file to get, let's call that zip train in R. And so here we have zip train, which is this data table with lots of columns. And the first one is telling you what is the label, the digit, that's an image of a number 6. And then the rest of the columns, V2 through V257, are the different pixel intensity values, right? So here we have, again, 7,291 rows, one for every different example of an image of a digit, and then different columns which represent either labels or the features, which are the pixel intensity values in the image. So how do we visualize that image? So, I mean, one way to do that is with ggplot2. And so here's what I'm going to explain you how to reshape the data so we can visualize it using ggplot2. So, so the first thing that we need to do, think about how we need to, how are these pixel intensity images, images represented in terms of these features? Well, if we go to the web page again, there's this info file where it says that there's 16 by 16 grayscale images, right? So so yeah, I mean, what we're going to do is we need to convert these 256 columns from V2 to V257 to display it as like a matrix of 16 by 16 pixels. So let's try to do that. Here, let's make a subset called zip sum, and that'll be just zip train of let's say just the first 10 entries. So zip sum is looks like this. And so let's say we wanted to just plot what those first 10 images look like. Well, like I said, we can use the ggplot2 library in R. And again, when we write the ggplot code, we're going to be writing code like geom point, AES, or not geom point, here we want to use a geom tile. And so the geom tile is going to basically draw a square, or they call it a tile, for every one of the pixels. And so we're going to do like x equals, you know, row, y equals column. Maybe let's say x equals row I, y equals col I. No, is that right? No, it should be the other way around. The x position should be the column number, y position should be the row number, and then the fill, there's a fill attribute that tells you how much should be shaded in, is going to be the well, some variable like let's call it intensity. We don't have any of these things created yet, but just to give you an idea of what the data needs to look like in order to visualize it. So let's call this zip. Let's call this zip sum tall, and let's do a fast set wrap according to the observation number. So what this means is that we need to create a data set. If we want to visualize this data set using ggplot2, we need to create a data table called, save it in a variable called zip sum tall with these 4 column names: col I, row I, fill equals intensity, and sorry, intensity and observation, those 4 column names. And then we can plug it into the ggplot for visualizing those images. So how are we going to do that? So there are a bunch of different ways of doing that, and you know what I can do is I can you know, show you how to right, probably the most maybe one of the most efficient ways to do this is to just use a matrix call. So so let's try to do that at first. So zip sum, first let's assign observation I variable. That's going to be from 1 to n. And so now we have this zip sum where we have this additional observation I with 1, it goes from 1 to 10 for each of the 10 rows there. And then if we do zip sum, and then we do by equals observation I, right here let's change this to I to be consistent. What this is going to do is we're going to execute some code for every for every instance of this observation variable. So it's going to execute some code for every row here. And what we want to do, well, if we look at this matrix function in R, you know, say that we have some values that go between 1 and 9, and we want to put that in a 3x3 matrix. Well, that's what it's going to look like. And so so is that going to work? Yeah, I don't know. Actually, I don't even think we need to use matrix here, because what we want is this data table with 4 columns. So in fact, what we want to do for every one of these observations is just assign a row and column number. So to do that, what we can do is, you know, again, we have these data which are going from V2 to V257. So we can actually just maybe select those columns. So let's try that. At .sd paste 0 V2 to 257, and let's try as numeric to get that. Well, is that going to work? Let's see. Because basically what I'm just trying to do is try to reshape the intensity values. Let's see if that works. Oh yeah, we can find a function data table, so let's just do that. When I is a data table, columns adjoined must be specified using on. Let's going on there? Oh, yeah, that's right. So this is happening inside of the .sd call. Right. So I think we can try to do comma. Comma with equals false. Maybe that will fix that. Let's see. Yeah, so take a look at that. So now we have some intensity values that we extracted. Now we have this data table with a lot more rows, 2,560 rows instead of just 10 rows. And now we need to assign, column and row numbers. So let's try that. So row I equals rep. This is going to be 16 by 16. Right, so 1 to 16, 16 times, and this is a call I equals rep 1 to 16. Each equals 16. So let's see if that works. So here then we get two additional columns where row I is varying fastest from 1 to 16, then call I stays at 1, goes down to 16, and then we have intensity and observation. So let's see if that works. Remember the name of this that we wanted to for the plotting is zip sum tall. So let's try that. Zip sum tall gets this thing. And let's see what happens when we plot that. So it looks like we're seeing something now. At least we see some numbers, right? But it looks like they're rotated. So it looks like we messed up the definition of the rows and the columns here. So let's try to redo that. Call I should be that, and row I should be that, and let's see if that looks like some numbers. Almost. Now they're upside down. So let's try row I equals negative that. Or we can do y equals negative row I here. Yeah, that makes more sense. So now what we can see is, I guess the other thing that we might want to add to this ggplot is chord equal, which will make them look like squares, like they should for pixel intensity values. And after that, we might want to do theme BW plus theme panel margin equals grid unit 0 lines. That'll decrease, save some space by putting all the panels together. I guess another thing that we might want to do is alter the color scale. So scale, fill, manual, scale fill gradient. How about low equals white, high equals black. And that looks like a pretty good visualization of the pixel intensity values. So yeah, so I guess that's pretty much all that I wanted to show in this first tutorial. I guess the only other thing, here in the panel titles, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But that's not telling us what the label was, so we might want to also include the label. So I think you can include that by observation I plus label. And I think here we would have to do label equals v1 because that's the first column name. So let's see if that works. Right, so now we get two strips for every panel, but we don't really know how to read them. So we can add one more argument to pass that ref called labeler equals label both. And that'll tell us what the variable name in each facet is. So here it says this is observation I. The label for this observation is 6. This is observation number 2, and the label for this one is 5. So here we can visualize all of the relevant information in the zip.train data set in this way. So this, its first screencast has just been to demonstrate how to download and visualize the pixel intensity data and their labels in R and ggplot2. Thanks for listening.